Okay, so we're into 5.5. We're going to talk about Z-scores. So this will be the first part of Z-scores for us in our study of statistics. So this is still in stats. There's only a couple more sections. We'll probably do a couple of days or parts to this. I'll try to keep it in that 20-minute range here. So what we're going to look at today, okay, this is section 5.5, and we're looking at Z-scores for normal distribution. Z-scores for normal distribution, and we're going to look at, first of all, what a Z-score is and a Z-score table and things like that. So when you're talking about Z-scores are the location, like if you look at the normal distribution table, we know where the percentages go. So what a Z-score table tells you, it's the table value represents the area to the left of the Z-score. Okay, so the formula for Z-score is quite simple. Let me just bring up my preview here so I know how long I'm going. Oops. Okay, I just want to move this over. There we go. All right, so let's start with the Z-score table. Or sorry, the Z-score formula, pardon me. Okay, so if you're doing a Z-score, statistical value, and what a Z-score represents is pretty simple, okay? So let's go with black here. Thin line. Okay, so to calculate any Z-score, the Z equals, okay, it's the whatever data point you're talking about, subtract the mean over the standard deviation. So the mean, or sorry, whatever data point is X, I think that's what your book uses. Let me check here. Yep. Minus the mean, and they use for the mean in the book, they use a fancy U over the standard deviation. So this is the Z-score. This is a standard deviation. This is the mean of the data. Okay, so again, we can use Desmos to help us speed up calculations for finding means and averages and standard deviations. And this is a data point. Okay, so we'll do a couple of calculations with the Z-score. So what does the Z-score give us? So I'm going to bring a table over here, a Z-score table. Okay, and the Z-score gives us the percentage of the area to the left of the Z-score. So to the left of the Z-score, and we'll draw the picture here. So here's the negative numbers. That's below the mean. Okay, and this is the Z-score. And then this represents these numbers underneath here. This number represents the Z-score. Okay, so if you had negative 1.45, you go 1.4 and then 5 would be right in here. So 1.45 negative is right there. Oh, that's 1.44, pardon me. Right there in this particular table. And that would represent, now what this number represents is the percentage of the area. So that would mean that if we think of a percent, 7.353% of the data is below that Z-score. And that Z-score is basically how many standard deviations you're sitting away from the mean. So if it's a negative score, it's below the mean. If it's a positive score, it's above the mean. If it's right on the mean, it's it's you have a 0, 0 z-score. You're right on the mean, right in the middle. Okay, so if we go down here, there's the positive set. So you can see everything above here. 50% is right there, 0, 0. That's right at the mean, right? 50% of the scores would be right below the mean, and 50% would be above the mean. Okay, and as you go farther and farther away, so if you're one standard deviation away, it would be 1.00, it'd be 84.134% of the data, 50 plus that extra whatever you have there. Okay, so a z-score represents, if we're drawing the picture, that's a normal distribution, and this is your point X. The z-score represents, this is going to be the percentage of data to the left of the z-score. I guess the z-score, not X there, sorry. To the left of the z-score. Okay, so if that z-score, and right at the mean is here. Everything below the mean is a negative z-score. Everything above the mean is a positive z-score. Okay. So let's do a couple examples using this formula of some data. Okay. So let me just pause here and find a couple, and then we'll work them out. Okay, so the first example that we're going to do is using the z-score to compare results of two different samples here. So let's do test scores. So let's say that your score on a test tests. Okay, so let's say for math, you scored 98, or let's not go that high. Let's go 77 with the mean being of, let's just say instead of being, of, let's say it was 73, and standard deviation of, let's say, 2 point, let's say 5.4. And in science, you have an 81 with a mean of, let's say, let's go 76, and a standard deviation of, let's say, 4.2. Okay, and which of the which exam is a better result? Use z-scores. Let's say compared to the class. Okay. Use z-scores. Okay, so, well, you could say, well, I got 81 in science, so that's better. But the average was also higher too. So, and then standard deviation was lower, so everybody was closer. So is it really that way? So what we're going to do is we're going to use the formula that we had, which was this one right here, and we're going to calculate the z-score, and then we're going to use the z-score table to see which one of them you have a better result for in terms of how many do you beat more of the population for which score. So the first step is to calculate the z-score. So let's do that. So step one is to calculate the z-score of both tests. Okay, so the z-score formula, let's go ahead and do that right underneath here. Z-score formula, okay, we're going to use this formula here, x minus the mean over the standard deviation. See you later. Okay, so let's do the first one. So 77 was your mark. The mean was 73. And the standard deviation was 5.4. So that's going to give us 4 over 5.4, which gives us a positive z-score because you're above that. So if you take your calculator out, 4 over that, your z-score is 0.7407. We'll go to 3 decimals because that, or 2 decimals, so that's all they got in the table. So we'll go 7.4. Okay. The second one that we're going to do here is 81 minus 76 over 4.2 equals. So I got 5 over 4.2. So this is going to give us 1.19. So the higher z-score means that you have more data to the left, more people below you, more of the population scored below you what you did. So you could say there we go, that's better. In science, my z-score was 1.19. Math was 0.74. Therefore, science was a better score. Okay, because it's a higher z-score. Okay, now the other thing that they can add to this question, we'll add a little bit. We're going to add, so step 2 is to look at the higher z-score for this case. Okay, so the other question that they can ask here is they can ask how much more percent of the population did you do better in science with? So let's ask that question. Which exam had a better result compared to the class? Use the z-score. Okay, so I could ask by what percentage of the population or by how much better, we'll say. Of a percentage of the class of a, I'm struggling with the word, how much better of a percentage of the class did you do on your science over your math? This is where we have to use the Z-score table. So we're going to look and see what the percentages are. So if we bring up a Z-score table, now the Z-score table in the book is on page 592, 593, I think. Sorry, yes, 592, 593. I'm going to use the one online so that we can look at it together, so that I had up there before. So let me pop that one up. Okay, so I'm going to look up the Z-score of the science, which was 1.99. So we're going to do science first. Look up science. So you're going to do this. You're going to have 1.19, and then you're going to have over here 0.74. And you're going to look up science and get a percentage. And you're going to look up math and get a percentage. Okay, and then the difference between the two is going to be how much better you did. So let's bring that table up again. All right, so let's look up on the table here 1.19. So 1.19 is right here on this table. Okay, that's 1.99, sorry, 1.19. Right there. 1.19 is 0.88298. That means 88.298% of the class. So 0.88298. So we'll put it in here. Okay, so that's that one. And then we're going to look up math. So that's the 0.74. Okay, 0.74 is right here. Okay, so that's 0.77035. Okay, so that means 88.298% all the way back like that, and 77.2. So this is the region here that you want. That's how much people you did better than in science than you did in math. So in the sense, you want the difference between the two. So you go then you subtract the two. So 0.88298, that represents a percentage. Subtracted 0.77035. Okay, for your math. So this is going to be 36211. 0. So that, therefore, you can say that you had an 11 point, and we'll just round it off to 3.3% better result in science. Better result in science. Okay, so this means that we've played science. You've actually beat 11.3% more of the people in the class in your science exam than you did in your math exam. Okay, so if there was like 100 people, it'd be about 11 people in the class. If there was 200 people in the class, it'd be 22 people. Okay, and that's kind of how you do Z-scores, do a comparison. Okay, we'll do one more quick one here, and then we'll do, in the second part, I'll do finding some warranties and things like that, working backwards. Okay, let's say, and I'll give you some practice like next day after part 2. Okay, so let's go with second example. This is example 2. Find the mark where you are better than 80% of your class, given the following bowling scores. Okay, so let's say that you're for your bowling club, your average score is 186, and your standard deviation of that score, let's say that it's 23. Okay, and we're always assuming. So what you want to do is you want to find the score where you're 80% better. So therefore, you're going to use Z equals the mean, or sorry, got that backwards. The point minus the mean over the standard deviation. Now we're going to rearrange this to get X by itself, because we want to find the score that you have to be 80% done. So how much do you need? How much do you need to score? 186? Okay, so the first thing we're going to do is rearrange it for X. So we're going to multiply both sides by the standard deviation. So Z times the standard deviation is going to equal X minus the mean. Okay, and Z times the standard deviation plus U is going to give you this point. Okay, so we have to find our Z score for 80%. So step 1, we know what that is. We know what that is. We know what the average is. We know what that is, but we have to look up what this is. So step 1 is to find the Z score for 80% of the data to the left. Okay, so you're going to look up 0.80000. Okay, so let's get our Z score table out again. Oops. Oops. That's the email. What the heck? Where is that? I got it all messed up here. Hold on for a second. Oh, there it is. It's right on the bottom. I hit it too well. Okay, so we've got to look for 0.88, or the closest we can. 0.88. So here we're looking. There's 7. here is 79995, and then so it's those two there. So which one's closer? This one here is 0.234 off, and this one here is 0.45 off. Okay, so this one's a little closer. So our z-score that we're going to use is 0.84. So our z-score, step one, look at the z-score. So the z-score equals 0.84. It's between 0.84 and 0.85. And I said, basically, you could pick either one and be close enough to write. I picked the one that looked closer to me. Okay, and then step two is to calculate the x value. Okay, so x equals z standard deviation plus the mean. Okay, so in our case, we had 186, the z-score that we looked up, 0.84, times standard deviation of 23 plus 186. So the score that you need to beat 80% of the club, or 80% of the people that bowled, just making sure the 23 was right, would be 0.84 times 23 plus 186. So I get 205.3, so we're going to say 205. So therefore, if I scored 205, I would beat 80% of the scores in the data. Of course, we're always assuming normal distribution. So that means you'd be in the top 20%. You'd beat 80% of the scores. Okay, let's check the time here. Okay, so that's about 28 minutes. So I'm going to stop there. Next day, I'm going to do a couple more examples, and then I'm going to give you some practice examples at the end of that. Because there's two more types of examples that I want to do, but I don't want to do them in short 20 to 30 minute videos. So we'll do that next day.